Electricity is essential to modern life. It is not just a luxury we use to run our gadgets and enjoy our leisure time, rather, it is a vital resource we rely on to carry out our daily tasks, generate revenues for our businesses, and provide public security, safety, and health. Flexibility and resilience in power distribution is becoming increasingly important to deal with the rising share of variable renewables brought on by decarbonization of the energy system, as well as the rising simultaneous load from power electronics, manufacturing facilities, heat pumps, and the charging of electric vehicles. Peak shaving, also called load shedding or peak load shaving, is a strategy employed by businesses to trim down their electricity expenses. It is particularly useful in cutting costly demand charges, otherwise known as capacity charges or capacity tariffs. The maximum peak load of electricity consumed determines these capacity charges, which make up a substantial portion of the utility bill. To reduce these charges, businesses and other large electricity consumers proactively manage their energy usage to minimize short-term spikes in demand. They can effectively shave the peaks by smoothing out their electricity consumption patterns, leading to lower demand charges and significant cost savings. In the energy industry, peak shaving refers to leveling out peaks in electricity use by industrial and commercial power consumers. Power consumption peaks are important in terms of grid stability, but they also affect power procurement costs. In many countries, electricity prices for large-scale consumers are set with reference to their maximum peak load. The reason is simple: the grid load and the necessary amount of power production need to be designed to accommodate these peak loads. Peak shaving versus load shifting. With peak shaving, a consumer reduces power consumption load shedding quickly and for a short period of time to avoid a spike in consumption. This is either possible by temporarily scaling down production, activating an on-site power generation system, or relying on a battery. In contrast, load shifting refers to a short-term reduction in electricity consumption followed by an increase in production at a later time when power prices or grid demand is lower. Dedicated generators or electricity storage facilities owned by the power consumer can be used to bridge high price or high load phases, but play less of a role if production will eventually catch up again. Peak shaving involves briefly reducing power consumption to prevent spikes. This is achieved by either scaling down production or sourcing additional electricity from local power sources, such as a rooftop photovoltaic PV system, batteries, or even bidirectional electric vehicles. On the other hand, load shifting is a tactic where electricity consumption is temporarily reduced and transferred to periods with lower power prices or grid demand. This is usually suitable for flexible loads that can easily be shifted without affecting operation, such as charging electric vehicles. Peak shaving can be done through demand-side management or supply-side management. The objective of demand-side management is to curtail demand by implementing various strategies. For instance, in the e-mobility use case, an energy management system can automatically limit the power allocated to electric vehicle charging infrastructure. In industrial scenarios, unused or unnecessary heavy machinery can be deactivated. Supply-side management involves leveraging local power sources to decrease reliance on the electrical grid during peak periods. Integrating energy sources, such as PV systems, batteries, or fuel cells, is crucial to enable this. Fossil fuel-powered sources, such as backup generators, can also do the job, but with many more emissions. Demand and supply-side management can be applied separately or in tandem. All methods reduce the load at the grid connection point, thereby successfully shaving peaks. Best peak shaving practices evaluate the load profile. Analyzing the load profile of a site reveals the electricity consumption patterns over time. The precise amount and timing of peak shaving can then be identified based on historical data. Load variability, which indicates the magnitude of demand fluctuations throughout the day, must also be considered. Sites with higher load variability must leverage a flexible and smart energy management system. Pick the right energy storage tech. Although an energy storage system is not a prerequisite to shave peaks, it is ideal from a supply-side management side. Cost, performance, lifespan, safety, and environmental impact are some of the variables to factor in when choosing the right energy storage tech. Batteries are the most popular option for home and small-scale operations due to their versatility and ease of installation. Hydrogen storage via electrolysis is increasingly popular for industrial use cases or smart districts, and thermal storage is an emerging field that has strong potential. Peak shaving can be configured to achieve different objectives. As such, operators must first set their priorities, whether that is minimizing electricity costs, maximizing grid stability, or minimizing emissions. This then defines the logic used in the energy management system's control strategy. This would then determine, for example, if scheduled control or predictive control is used. Scheduled control adheres to a predetermined charging and discharging schedule based on a site's load profile and tariff structure. Predictive control, on the other hand, uses historical and real-time data, as well as load and grid forecasts to optimize charging and discharging. Regardless of the specific objectives, all energy assets in the system will be monitored and controlled in real time and loads optimized according to user-defined peak thresholds. Future of peak shaving. Peak shaving is increasing in popularity not only due to the significant financial wins it enables, but also due to changing energy regulation. While it is currently primarily a tool for businesses, this may soon be extended to private households. In Austria, for example, the proposed implementation of grid capacity tariffs for private households indicates a commitment to managing power peaks and optimizing electricity usage. It will be important to monitor the progress of the corresponding legal amendment and assess its potential implications for consumers and the electricity grid. Meanwhile, in Germany, the new paragraph Section 14A in the Energy Industry Act will provide an additional incentive for operators to act in a grid-optimized way and shift their energy consumption to lower demand periods. This measure is designed to encourage a more stable grid through methods like peak shaving. Why is peak shaving important? To understand the importance of peak shaving, it is necessary to examine how peak demand affects electricity prices. There are typically two components to an electric utility bill. Customers pay for electricity based on consumption, measured in kilowatt-hours, kilowatt-hour, and demand, measured in kilowatts, kW. Demand charges usually apply to commercial and industrial customers, who tend to have higher peak loads than residential customers. However, it should be noted that with the transition to electric mobility, the surge in the number of electric vehicles, and with the addition of residential fast-charging infrastructures, demand charges could have a significant impact on residential electrical utility bills. The contribution of demand charges varies geographically, but typically ranges from 30% to 70% of the customer's electric utility bill. Thus, it is important to understand how demand charges work and how peak shaving through battery energy storage systems can minimize electricity charges without compromising the operation of any given application. How does peak shaving work? The two charges that can significantly affect the rate at which industrial and commercial users pay for electricity include demand charges and consumption charges during on-peak intervals. As mentioned above, peak shaving is a strategy for mitigating demand charges and usage during peak times, thus it requires altering the operation of an application or implementing storage capabilities to store energy for later use. Since shutting down or slowing productivity contradicts business goals and objectives, often businesses bear the cost of demand charges and on-peak charges, perhaps in part due to lack of knowledge about energy storage technologies. A battery energy storage system is a method for storing electric charge using electrochemical storage units so that it can be utilized at a later time with the help of intelligent software that balance electricity supply and demand. Benefits of peak shaving is the most effective way to manage utility costs for customers with demand charges, but it can also mitigate consumption charges and offer benefits to other stakeholders as well. For example, self-consumption of embedded renewables can significantly reduce electricity bills. According to a research study by the Journal of Energy Storage, it is possible, though not guaranteed, that this operation may consequently reduce peak flows on the local distribution network, thus benefiting the distribution network operator DNO and subsequently other electricity consumers in the distribution area by lowering future distribution charges. Implementing on-site storage in addition to solar photovoltaic capacity means that you get the biggest power bill reductions possible. You can use solar power from your panels during the day to charge your on-site batteries. The stored power bears minimal cost, and any extra charging can, if necessary, take place during off-peak intervals using the grid. When power is needed, users have the flexibility to choose electricity source based on the most affordable source at the time, whether that is solar power directly from the panel during the day, stored solar energy, or stored grid energy during off-peak intervals. It is worth noting that a solar system is not required to take advantage of the benefits of energy storage systems. Peak shaving and emergency backup are examples of application that work without solar arrays, and customers can still benefit from the cost savings, stability, and resilience that energy storage units provide. Peak loads and grid usage fees. Peak loads are not popular with grid operators. They must design the grid based on the maximum amount of power that will be needed. Nevertheless, everyday operation at many industrial companies such as powering up or increasing a production process can cause fluctuating loads on the grid.